On my next problem, I have a negative in front as well, so the first thing I want to do is factor out a negative. The common factor between 15, 10, and 25 looks like 5. And then the common factor between the variables u to the 4, u cubed, and u, which is just u to the 1. Then I go back and divide. Negative 15 divided by negative 5. Be careful there, a negative divided by negative is a positive. U to the 4 divided by u to the 1. I don't really necessarily need to put that little 1 there, but it might help you when you're subtracting. So that gives me 3u's. Next term, negative 10u divided by negative 5. That's positive 2. U cubed divided by u to the 1. That's u to the 2. I'm subtracting my exponents. Positive 25 divided by negative 5. That's going to be a negative 5 because a positive divided by a negative is a negative. A lot of students get that one confused. U to the 1 divided by u to the 1, well, that's just 1. Do I need to multiply a times 1 there? Well, not really, because I already had a 5 there. So I already had a term, and 5 times 1 is just 5, so I believe I am done there. To check for completeness, look at the terms inside the parentheses. Is there anything else that could be factored out that I didn't get the first time around? I think I'm good. Okay, so on the next problem, I'm looking to see if there's anything common. Well, this is the first time when we have parentheses here. So I'm not only looking at the first terms, but I'm also looking at the inside of the parentheses. So I have two very long terms here. What do you see common between 7y and 14z? Well, it looks like 7 and 14 both have a common factor of 7. It also looks like both terms have a common factor of the parentheses 3x plus 9. So 3x plus 9 is common in both. So I started out with two very long terms, right? One very long term here and one very long term here. So that means inside my parentheses I should have two terms. So looking at the first term, 7y times the parentheses 3x plus 9, and I'm dividing it by the blue GCF, 7 times 3x plus 9. So 7y divided by 7 is just y. The parentheses 3x plus 9 divided by the parentheses 3x plus 9, that's just 1. Do I need to write multiply by 1? Well, not really, because I already have a term there. Now, if there wasn't any term there, I wouldn't be required to put a 1. Alright, so that's the first term. Let's look at the next very long term. Negative 14z times 3x plus 9 divided by 7 times 3x plus 9. Well, let's just do the first parts. Negative 14z divided by 7, that's negative 2z. And then we have 3x plus 9 divided by the parentheses 3x plus 9, which is 1. But again, we've talked about we don't really need to write that 1 because we already have a term there. Now this looks like we're done. It was a little bit harder, but actually we're not done. And the reason we're not done is because if you look inside the parentheses, you should have no more GCFs left. Well, inside y and 2z, there's nothing else common. But look inside the first parentheses that we factored out. 3x and 9. Do you see anything common between 3x and 9? Well, I do. It looks like there's a common factor of 3. So if I factor out a 3, that gets me x plus 3. But I still have that blue 7 in front. I haven't gotten rid of him. He's just still there. And I still have the red parentheses y minus 2z. So it's just this middle factor that I factored out a little bit more. And to simplify at the end, I can take the 7 times 3 and get 21. Along with all of the rest of my factors. This is now completely factored because each term, x plus 3 in the parentheses and y minus 2z, doesn't have anything else in common, and now this is completely factored. On the next problem, we have 15x times the parentheses y minus 3 minus 5z times 3 minus y. Well, you might look at these two parentheses and notice that they're not exactly the same like the last problem, where we had 3x plus 9 and 3x plus 9 in both of the terms. but they're really close. Y minus 3 and 3 minus y are very close. So the way I like to deal with this problem is if the y is in front in the first term, but it's in the back in the second term, what I'd like you to do is rearrange one of the terms so that their y's are in the front and the numbers are in the back. This is going to help us be able to factor things out a little bit easier. Now just by rearranging that, I can see that these two terms aren't very close, but they're not exactly the same. In fact, they're only off by a negative. So what I would like to do is I'd like to factor out a -1 out of the second parentheses. So I want to factor a -1 out of this term. So if I factor out a -1, that leaves me with positive y, because a negative y divided by -1 is positive y. Positive 3 divided by -1 is -3. But I still truly have all of the other terms still there. I have that -5z. I have all of the 15x times y minus 3. And now this one looks a little funny, so let's clean that up right here. When you have a -1 times a -5z, that's really a plus 5z. And now I have the two parentheses with the y minus 3. One fast way of doing this is if you are ever trying to factor out a -1, you can just basically change all of these signs, the plus, minus, and that's what it really turned out to be, plus a positive y and a minus 3. So if you want to do that a little faster, you probably could just change all the signs when you're factoring in a -1. You just have to make sure you do it to all of the terms, the GCF and inside the parentheses. And now at this point I can proceed kind of like the problem we just did. I have two very long terms, and what do you see common in both of them? Well, in the 15x and the 5z, I can see a 5 common. In the y minus 3 and the y minus 3, now they're exactly the same, and they are common. So I have two terms left. Okay, I started with two terms, so I need to have two terms left inside my parentheses. So in the first term, I have 15x times y minus 3 divided by 5 times y minus 3. Well, 15x divided by 5, that's 3x. Y minus 3 divided by y minus 3, that's 1. Again, I don't really need to write multiply by 1 because I already have terms there. And whenever you take a term and multiply by 1, it really doesn't do anything. Now I have a plus, because remember when we took a negative times a negative, that turned into a plus sign right here. So I have a positive here. 5z divided by 5, well, that's just 1z. And probably don't need to even write the 1, because now that I have a z there, I can just write z. Y minus 3 divided by y minus 3 is 1. Again, don't need to really write that 1. Now I have completely factored this problem. There is nothing else to factor out of the 5, out of the x, y minus 3, or the 3x plus z. So now I know I am completely factored. If you want to take a moment to distribute this out and distribute out the original problem, and then you can see that they truly are equal, and they're just two different ways of writing the same expression. Our answer is considered factored because all of our terms are being multiplied. So we know we have truly completely factored this problem.